Hello everybody, I hope you are doing well. In this presentation, I'd like to give you some information about Internet of Flying Things, IoFT, or the Internet of Drone Things, IoDT. And there is another paper in the field of optimization IoT drones using cellular networks. This is the contents. First, I'll provide you some information about UAVs or drones, then flying ad hoc networks, then IoT challenges, benefits, then IoFT and Internet of Drone Things, IoDT. Okay, the main important things here is that the words drone and UAVs are exactly the same and we can use them interchangeably. So anywhere you see a drone or UAV, they are the same. What's the UAV? UAV is a smart aircraft system that we can control it remotely and use onboard computer system. The purpose of providing drone was military. It traced back to World War I and II. That time they used hot air balloons as the first drone, as you can see here in this figure. There are many classifications for UAVs. If you read the UAV papers or FANET papers, you can see them. But I provided three main UAVs categories, including consumer drones, enterprise, and government drones. Okay, here let's take a look at the components of the drone or UAV. We have the airframe, which offload the UAV components, and flight controller, the communication interface like omnidirectional antenna, sensors, and single board computer, GPS, battery, RFID reader to read the RFID tags, and many other mechanical components. There are 7 generations for drone technologies, ranging from the simplest one, the drones for kids as a toys, to the complex one that are provided for IoT and cloud applications. Okay, what is flying ad hoc network or FANETs? FANET is a subclass of mobile ad hoc networks. As you can see here, there are several UAVs that connected to each other in a wireless ad hoc manner, and you can see the ground station as well here, and there are some communication links. The communication in FANET can be like UAV to UAV communication, UAV to ground station communication, and a hybrid communication. For example, when this UAV connect to this one, and then to the ground station, which is a multi-hub communication. Flying ad hoc networks bring many advantages for us. The first one is the high degree of mobility in FANETs facilitates the communication between UAVs without overhead and information loss. We have also peer-to-peer connectivity that is for collaboration of UAVs. As I've mentioned, UAVs can communicate to each other using a direct communication, a one-hub communication, or a multi-hub communication. Communication range in FANETs is more than other ad hoc networks because the UAV want to communicate to the ground-based station. But we need some communication hardwares to obtain the radio links in some situations. FANETs support heterogeneous sensors. Each UAV has its own methodology to distribute data. And FANETs support complex environmental operations like random block links or higher node mobility. So there are the advantages of FANETs, and there might be some other advantages that you can see in the papers. Although flying ad hoc networks provide some benefits, there are several challenges that should be addressed. The first one is connectivity. The low density and high mobility of UAVs leads to link fluctuation. This link fluctuation leads to connectivity issues, and these connectivity issues can decrease the performance of the network. UAV battery is limited. The battery is used for flight communication, data processing, and other tasks. So it's a limited battery. The UAV storage and computing resource capacity is also limited. So in some situations, UAVs need to offload collected data to the ground station that have higher resource capacity for computing and storage. There is also transition delay. We have multi-hop communication in FANETs that can provide end-to-end connectivity, but it increases the transmission delay because we have multi-hop communication. The next one is interface management. Due to the limited bandwidth capacity and rapid changes in topology in FANETs, we might have a difficult interface management. They make the interface management difficult. UAV's collaboration and cooperation is another issue in FANETs, that when we are trying to accomplish a mission, the collaboration on UAVs is another challenge that should be addressed. Okay. IoT or Internet of Things tries to provide connectivity between all things like sensors, actuators, mobile devices, and such like. IoT, provides many advantages for us, but there are some challenges, like IoT node deployments. The placement of IoT nodes in places without proper power supply is an issue. Replacing the battery of IoT nodes is a difficult task. IoT services availability. IoT services are not always available anywhere, anytime. So it's due to the inaccessible IoT node deployment. In some situations, we need to communication protocol to provide continuity of IoT services. Weather conditions is another challenge in IoT that can destroy the IoT coverage. For example, natural disasters or terrorist attacks can destroy the IoT coverage. The high number of client queries. We have many sensors that sense the client queries. To handle this huge amount of queries, we need to have IoT resources, storage, energy, processing power, and so forth. Energy demand of IoT nodes. As we already mentioned, the IoT nodes and sensors have limited batteries, so we need efficient management and power supply for nodes. Okay, I've mentioned the challenges of IoT and FANETs to reach this point. The Internet of Flying Things, or IoFT, and the Internet of Drone Things, or IoDT, have been proposed to solve the FANETs and IoT challenges. UAV can improve the performance of the IoT in terms of coverage, reliability, scalability, and the connectivity. What benefits IoT and IoFT and IoDT provide? The first one is connectivity and coverage. IoFT provides both internet connection and local connection using FANETs, so it can provide connectivity and coverage. In terms of reliability, the mobility and high attitudes of UAVs decrease the signal blockage and shadowing and such problems. So by doing this, we can make the connections between devices more reliable. Data processing and storage was another challenges in IoT and FANET, that we can address this challenge using IoT cloud computing that I'll show you in the next slide. For real-time services, as I've mentioned, services are not always available, but we can use edge computing to solve this issue. Resistant to weather conditions, IoFT recovers the missed connectivity using some approaches. And the battery of IoT nodes is limited, but using UAVs, we can provide IoT ground users energy and provide power for them. There are three main technologies that shape the IoFT and IoDT. The first one is cloud computing, which is the key player in IoFT. It relies on resource sharing, which is the primary requirements of any IoT platforms. Using cloud computing, end users can access all types of services, cloud services, from anywhere, anytime, just by having devices connected to the internet. There are there are three layers in computing, in cloud computing. The UAV front end that collects sensor data in the sky, and the collected data should transmit to the cloud for storage and processing. This data can be used for example, fire detection, pollution monitoring, and such like. The next layer is edge computing. It extends cloud computing capabilities to real-time sensitive IoT applications. It reduces computing loads by handling some UAV data at the edge IoT devices without the intervention of cloud. And the next one is fog computing, that sometimes combined with cellular networks. As you can see here, it's like an intermediate layer between flying cloud computing and UAVs. With fog computing, IoFT applications can perform computations of solutions locally. And when we need, we can use ground stations for more computational computing. And the sensors and IoT protocols like ultra wideband, BLE, Zigbee, and some other IoT protocols. Okay, here we have some applications for IoFT and IoDT that I listed them here. The first one is agriculture, the smart and advanced monitoring. For example, the ease of utilization and GIS mapping in smart agriculture, and many other papers. The environmental pollution monitoring, for example, there were some papers that were about smart river monitoring to control the water pollution, and the air pollution monitoring system. We can use the IoFT in disaster management, for example, for detect the fire of the forest, and the video streaming surveillance, delivery and health care, underwater operations, and for military. That was the first purpose of creating drones, for border surveillance, early threat detection, object tracking, smart city, smart home, smart industry. There are many applications that can use the IoFT and IoDT to improve the network. Here I've listed only three of the existing works. The first one is using IoFT for crop quality improvement in agriculture. There are some IoT-based drones and Raspberry Pi and various sensors that sense the environmental data like temperature, the humidity of the soil, and other parameters. The Raspberry Pi collects data from sensors and sends this data to the cloud-based storage area for further operations, for processing, analysis, and such like. The second one is air quality monitoring. There are some papers in this field that, for example, one of them has 4 layers. The sensing layer, which includes, ground devices and UAVs that collect real-time air quality data from environment and transmit them to the transmission layer, the next layer. Using wireless communications. The transmission layer, which consists of base stations, base stations guarantee bidirectional communication between sensing layer, the first one, and the next one, the processing layer. The processing layer, there is some, in processing layer, there are some web servers and database servers that receive air quality data using IoT communication from the transmission layer, and it analyzes and predicts air quality values using, by using some prediction methods. And then last one is presentation layer. It provides graphic interface for users and system managers. And there is also a work for early fire detection. It includes 3 layers: edge computing layer, fog computing layer, and cloud computing layer. That we had these layers in, as a technologies for IoFT. The edge computing layer provides UAVs with low latency accesses to services. The fog computing layer accomplishes most energy consuming tasks like classification, recognition of the images, selection, capture images by UAVs. The cloud computing layer select the images from fog computing layer and for further processing and analysis of the images. And finally, the IoFT, has some challenges. The first one is collision and interface. There might be many collision and interface because we might have, the UAVs, mobility UAVs. So we need to optimize UAV trajectory, UAV path planning, UAV IoT resource allocation, and find the optimal attitude of the UAVs. By doing this, we can decrease the collision and interface. The next one is UAV deployment. The UAV deployment, we need to find the optimal location of the UAVs using some machine learning techniques and, optimization heuristics like PSO, ACO, and colony optimization, and other algorithms. And we have also UAV selection. That for select the UAVs, we need to pay attention to remaining UAV energy, the required task energy, distance to task location, UAV speed, and many other parameters. The UAV path planning is also another challenge. The energy consumption, which some works use wireless medium to encounter this problem. The security and privacy issue. Many works have pay attention to the security and privacy in physical layer, but there are some works that are trying to handle security and privacy in transportation and application layers. And so we can, have some relay selection methods, multi-antenna arrays to provide security. UAV control and management is another issue. Control and management from remote internet locations become, it is complex. because of the frequent data transmission between UAVs and IoT ground devices. So we need some UAV control functionalities like data management, UAV localization, and group management. And the last one is data rate and coverage, that we need to provide high data rate with wide area coverage anywhere, anytime. So the coverage is another issue. And you can see here I've chosen 3 papers: the IoDT, which is the first international conference on suitable technologies for computational intelligence, and it's written in 2020. The other paper, another paper is from the Computer Communications Journal, written in 2021. And the last one is a conference again, IEEE conference, written in 2020. I hope you enjoyed this video. Good luck.